Welcome to our YouTube channel. Myself Lavanya.
Myself Kavin. I am Lokesh.
I'm Devadara.
We are third year students of Mechatronics department from Kongu Engineering College.
In this video, we are going to show our mini project soccer robot along with its working model.
We have created our own soccer robot which can control by using smartphones.
The components used in our soccer robots are Node MCU ESP8266, 12-volt battery, L298N motor driver, 150 RPM Vivo motors, rubber wheel 4 pieces, jumper wires, mini breadboards, and small wooden pieces for building frame.
Now we are going to see the step-by-step connections of this soccer robot. First, cut a foam or any kind of board in a preferred dimension. Secondly, glue the 4 gear motors to the foam board. Then, pass the motor cable to the back through the acrylic hole. Circuit diagram. Here is the schematic diagram for our soccer robot. We control the DC motors through L298 motor driver IC. This is a high power motor driver capable of running 5 volt to 35 volt DC motor at a maximum of 25 watts. You can use 200 to 300 RPM DC motor for this application. The main control unit is ESP8266 board, which connects and controls the entire circuit and equipment. Then connect the battery to the L298 motor driver power supply input. Connect all 6 inputs of L298 to ESP8266 D3, D4, D7, D8, D5 and D6 pin. Then connect the output pins of L298 to left and the right motors. Then attach the motor driver board and ESP8266 to the top of the board. Tightly screw all the components and mount them on the chassis. Afterwards, connect the gear motors to the motor driver board. For this, you can refer the circuit diagram.
Here we are going to see coding part of our soccer robot. In this code is used to dump in a node MCU which is used to control our soccer robot as per our specification. Here we are defining enable A and enable B to speed motor right and left, and input 1, 2, 3, 4 to the L298N motor driver right and left as well. As include ESP8266 Wi-Fi.h, as include Wi-Fi client.h, as include ESP8266 web server.h. These 3 code are responsible for connecting the Wi-Fi to the node MCU, which with the help of this we can easily connect the Wi-Fi with our mobile phone. String command int speed equal car equal to 800, int speed coefficient equal to 3. These code are responsible for initiating or declaring the speed of the robot at 800 and coefficient 3. Constant car SSID equal to node MCU car. This line is responsible for the soccer robot name. When we are turn on the Wi-Fi in our soccer bot, as well as when we are searching the name of the soccer bot, node MCU car will be displayed in our mobile phone. This line is very important to connect with our mobile phone. ESP8266 web server 80. This code is responsible for connecting a IP address 80 to the web server. Now we are going to main part of our coding part, void setup. Here, as we defined before, we are connecting these pin to the output port. Enable A, enable B, input 1, input 2, input 3 and input 4. Here, serial begin 115200 is responsible for baud rate to set in the frequency. Wi-Fi.mod Wi-Fi AP, Wi-Fi.soft AP SSID. These codes are responsible to connect the Wi-Fi. Means node MCU's Wi-Fi is able to enable to connect with our mobile phone. IP address my IP equal to wifi.soft API IP, serial.print API IP address, serial.println my IP. These codes are responsible to connect our node MCU with our mobile phone using IP address. So we have two options, that is, as we seen before, we can connect with the help of Wi-Fi, the word node MCU card, or with the help of IP address to our mobile phone. Starting web server. Server on HTTP handle root, server on not found HTTP handle root, server.begin. This code is responsible to connect the server. When the server is on, it should start with a starting place. If the server is not found, it should run on the same place. When the server is begin, it should go for the next line. Here we came for the main code of our robot, which is used to move our robot forward, backward, right, left, rotate, etc. Here we are going to see void go ahead. Void go ahead is nothing but moving our robot forward. Digital write and digital analog are used to read the input digit or either digital nor analog. Here enable 1 and enable 2 are motor 1 and motor 2. When we are doing forward, motor 1 will be low, means 0, and motor 2 will be high. As well as the enable A will be speed card. As we seen before, speed card have a specified value which will be enabled here. Then we are doing an input 3, that means motor 3 and motor 4 low and high. This is the same thing we are doing for void go back and void go right and void go left. And also we are doing this same thing for void go ahead right, void go ahead left, void back right, void back left. So these things are in.
First, connect the USB cable between the node MCU and computer. Then open the Arduino IDE and paste the above code. Check for the port number as this may change from every computer. Just check this by clicking on Tools and Port. Now we need to select a proper board type to do this. Select Tools, Board and ESP8266 board followed by selecting Node MCU. Then upload your code. After uploading the code, open the Android app installed on your phone and connect it with the Wi-Fi. Now you can control the robot using your mobile phone. To move the robot in forward direction, press the up arrow key, and to move it backward, press the down arrow key. Similarly, to move the robot left and right, press the left and right arrow keys.